If you're a curious mind, then you absolutely need to hear about the wildest, most mind-bending experiment in all of physics. This isn't just a story for scientists in white coats. This is a tale that shakes the very foundation of how we understand reality itself. Imagine an experiment so strange, so counterintuitive, that it's left even the greatest minds in history scratching their heads for over a century. Welcome to the double-slit experiment, a true cornerstone of quantum weirdness. The double-slit test isn't just famous, it's pure quantum magic. It's the experiment that revealed the universe doesn't always play by the rules we expect. In fact, it's the reason we talk about particles and waves, and why the quantum world is so different from our everyday experience. Let's break it down and see why scientists are still baffled. Even today, with all our technology and knowledge, the double-slit experiment remains a puzzle that challenges our deepest assumptions about nature. Picture this. Back in the early 1800s, scientists like Thomas Young set up a simple experiment. They shone light through two tiny slits in a barrier, expecting to see two bright spots on the wall behind, just like you'd expect if you shined two flashlights through two windows. But what they actually saw was something no one predicted. Instead, they got a wild ripple pattern. Bands of light and dark, like the ripples you see when you toss two pebbles into a pond and the waves overlap. This was the first hint that light could behave like a wave, not just a stream of particles. This discovery was revolutionary. It meant that light, which everyone thought was made of tiny particles, could also act like a wave, spreading out and interfering with itself. The double-slit experiment became a key piece of evidence in the debate about the true nature of light. Fast forward to the 20th century, and scientists decided to try the experiment with electrons, tiny particles that make up atoms. They fired single electrons, one at a time, through the slits. You'd think each electron would just go through one slit or the other, right? But no. The same mysterious pattern appeared, as if each electron was interfering with itself, behaving like a wave and a particle at the same time. And guess what? The mysterious pattern still appears, even when you send the particles through one by one with no chance for them to interact with each other. It's as if each particle is somehow aware of both slits and chooses its path based on possibilities, not certainties. It's like each particle is playing both sides, wave and particle, until we peak. This is the heart of quantum superposition. A particle can exist in multiple states at once, only settling on a definite outcome when we observe it. The act of measurement itself changes the outcome. When we try to watch which slit the particle goes through, the interference pattern disappears, and we're left with two simple spots, just like classical physics would predict. It's as if the universe doesn't want us to know both the path and the pattern at the same time. Recently, researchers stripped the experiment to its bare bones. Single particles, paper-thin barriers, basic detectors. No fancy tech, no complicated machinery, just the essentials to see if the weirdness would go away. But the same quantum weirdness, still there. No matter how simple the setup, the universe keeps playing its strange game, refusing to reveal all its secrets at once. Over and over, scientists have repeated the experiment with photons, electrons, even large molecules. Each time, the results are the same. The quantum world doesn't care about our expectations. It's proof. Even at the simplest level, nature doesn't play by our old-school rules. Why does this matter? Because it means the universe is far stranger and far more fascinating than we ever imagined. It shows the universe is fundamentally wilder than we ever imagined. The double-slit experiment is a window into a world where particles can be in many places at once, and where reality itself seems to depend on whether or not we're looking. Every time you observe, the pattern vanishes, as if reality changes when we look. This is the famous observer effect, and it's one of the most mysterious aspects of quantum physics. This experiment has inspired countless debates, paradoxes, and even thought experiments like Schrödinger's cat. It challenges us to rethink what we mean by reality and observation. So next time you hear someone say quantum physics is just math, remember the double slit. It's a real experiment, with real results that anyone can try, and it never fails to surprise. Quantum magic is very real. The double-slit experiment is a reminder that the universe is full of mysteries waiting to be explored, and that sometimes the answers are stranger than fiction. Hit subscribe and let's chase the mysteries together. There's a whole universe of quantum wonders out there, and we're just getting started.